Good day, everyone. My name is Heherson Cabrera, and I am team teaching with Dr. Limuel Tayo for this course, BE121, Chemical Analysis in Bioengineering. Okay, so a little bit of background about myself. I graduated from Mapua University with degrees in chemistry, chemical engineering, and biotechnology. So by profession, I am a licensed chemist and a licensed chemical engineer as well. But I've been teaching since 2015, okay, under the biological engineering program. So yung mga subjects na tinuturo ko usually is yung mga subjects that discuss chemical engineering principles, but for biological applications. Okay, so for example, transport processes, biological engineering calculations. Also, those subjects that are quite math intensive, like biomechanics. Okay, but today, for this course, from weeks 9 to 11, ako yung makakasama ninyo. And the part na na-assign sa akin na ituro ay yung spectrophotometry and its applications. Okay. Let's start by defining what spectrophotometry is. And you might hear these two words usually, yung spectroscopy tsaka spectrophotometry. Okay? May panagkaiba yung dalawang yan. Pag sinabing spectroscopy, so it's the branch of physics that study the interaction between matter and energy. Okay? While yung spectrophotometry, kaya may prefix siya or suffix na metry or metric, it's because in this area, you are measuring something. And that's where spectroscopy comes in. Because yung spectroscopy, ang application niya in our professions, okay, at least in chemical and biological analysis, is that yung interaction between matter and energy, okay, we can infer some useful information or data from them, okay, that enables us to do chemical or even biological analysis. So again, spectroscopy is the interaction between matter and energy, while spectrometry is, or spectrophotometry is the measurement part, okay, the application part. Now, before we go to your spectroscopy or spectrophotometry, we would like to discuss first the nature of light and then the nature of matter. Remember, in spectroscopy, these two interact. So let's start with light. So si light, or more specifically, electromagnetic radiation, okay, it exhibits both wave-like properties and particle-like properties. Okay? So, ito yung itsura ng iyong electromagnetic spectrum, or at least it's showing the direction of propagation of the light beam. So pag sinabi natin light, it does not really refer to the light as we know it, or yung tinatawag natin visible light, but rather the entire spectrum of your electromagnetic radiation. So makikita nyo, ito yung itsura niya. So you have here an electric field and a magnetic field. And these two are in parallel and they are oscillating. Okay? So, in terms of a wave, we can describe these following properties. Number one, wavelength. So wavelength is simply yung distansya between adjacent peaks of the oscillating field. So from here to here, that is a measure of your wavelength. Whilst the frequency naman, it describes the number of wavelengths that pass a particular point in space per unit time. Okay? Wavelength is measured in units of length. Okay? And frequency will be measured in terms of per second or hertz. Now, there is a relationship between wavelength and frequency. So if you go back to our diagram of the electromagnetic waves, okay, kapag mas malaki yung wavelength, all right, what happens is that frequency will be smaller, or vice versa. So they have an inverse relationship. Okay? So if the frequency is higher, ang ibig sabihin nun, napakadaming wavelength ang nag-pass through at that particular point in space and time. And that only means that yung wavelength ay maliit. So they have an inverse relationship. And they can be related by this constant c, which is simply the speed of light or speed of electromagnetic radiation. Okay? So the wavelength is inversely proportional to the frequency. So frequency, we give it the symbol Greek letter nu, as you can see here, while wavelength is lambda. So that's how you view electromagnetic radiation as a wave. Okay? But again, you can view it as a particle. Okay? So if you view it as a particle, electromagnetic radiation, sabi, is consisting of packets of energy called photons. Okay? So the energy of each photon is directly proportional to the frequency. So thus you have here the equation that energy is equal to h times the frequency. So the constant of proportionality that you see here is what we know as the Planck's constant. So the value is 6.626 times 10 raised to negative 4 joules second. And you don't really have to memorize this number because it's in your calculators. Okay? Now here is the electromagnetic spectrum as we know it. And if you go from left to right or from right to left, nagkakaroon ng change in terms of frequency or wavelength. So from right to left, nag-i-increase si frequency. Therefore, from left to right, nag-i-increase si lambda. And if we consider some specific sections of this electromagnetic spectrum, okay, let's say, kunin natin yung part from 400 to 700, okay, nanometers. Remember that wavelength is measured as a unit of length. So usually we'll have units like nanometer, picometer, angstrom. Okay? So if you take that section, ito pala yung sinasabi nating visible radiation or light as we know it. Okay? And this part of the electromagnetic spectrum can be further resolved by refraction. And if you will see, okay, ito siya, yung colors of the rainbow. Okay, yung Roy G. Biv na tinatawag. And if you are going to take note here, yung 400, okay, corresponds to the redder part of the visible radiation, while 400 corresponds to the more purple part of the visible radiation. Since 400 is greater than, is less than 700, okay, ibig sabihin 400 is more energetic. Remember that frequency and wavelength, they are inversely related. So the lower the wavelength, the higher the frequency, and the higher the frequency, the greater the energy. So the purple part will be more energetic as compared to the redder part. Okay, now what are the other parts of the electromagnetic spectrum that you can see here? So you have here ultraviolet, okay, or UV. Kaya nga siya ultraviolet kasi it's after the violet part of the visible radiation. Well, si infrared, kaya siya tinawag na infrared kasi after siya ng red part ng visible radiation. Okay? And after infrared, we have the microwaves and the radio. So these are less energetic parts of your electromagnetic spectrum. Pero yung more energetic parts will be yung X-rays and gamma rays. Okay. So what are the applications? So depending kasi on the type of radiation, whether it's X-ray or visible light or infrared, if you interact that kind of energy with matter, mayroong mga changes na nangyayari, and we call this quantum changes. Okay? And because these types of radiations have different wavelengths, they have different frequencies, ibig sabihin iba-iba sila ng energy. So, iba-iba rin yung nangyayari sa matter natin. So for example, let's start with visible and ultraviolet radiation. Okay? So you can see the values of the wavelength and frequency. Okay. Now, ang sabi, kapag you apply visible and ultraviolet or even X-ray sa matter, what happens to the atom is that there will be a change in electron distribution. And we call that electronic transition, wherein some electrons, okay, transition from one energy level to another energy level. Okay, yun yung ginagawa ni visible and ultraviolet radiation. Yan yung change na nangyayari. Paano pag nilakihan natin ng kaunti yung radiation, let's say X-ray or gamma ray? So hindi na siya basta-basta electronic transition lang. But rather, it's change of nuclear configuration now. Okay? So hindi na yung electron ang naapektuhan, pati nucleus naapektuhan na. Okay. But what if we have some, radiation na mas less energetic, like your infrared? So what happens if you interact infrared radiation with matter is that you don't expect electronic transition. You don't expect change in electron configuration. But what can you expect is that if you have a molecule, for example, imagine this as let's maybe carbon monoxide, I don't know. Okay, so may bond between the two, of course. What happens is that nagkakaroon ng vibration. So that's the effect of infrared. Vibration ng molecule and other movements, okay, along that bond between two atoms. If you have a microwave, it could be as simple as change in orientation. And if you have NMR, for example, change in spin. So ibig sabihin ng change in spin, okay, remember that in your electrons, it could have two spins, no? Plus 1/2 or minus 1/2. Or in your nuclear spin, pwede rin maapektuhan siya. Now, what are the types of energy transfers? So, na-discuss ko na kanina. Changes in the quantum state like electronic transition or vibration ng molecule, etc. So, but for energy transfers, okay, when we call it absorption, usually ang nagpa-participate na electromagnetic radiation is gamma rays, X-rays, UV, even IR, microwave, and radio. So these types of energies can all be absorbed. And depending kung ano yung ginamit mo na radiation, for example, if you use UV-Vis, thus we have what we call a UV-Vis spectroscopy technique. And we have UV-Vis spectrophotometers in your laboratories. Okay? Or even atomic absorption spectroscopy. I think we also have this in our labs. And if you use IR instead, absorption pa rin naman yun. It's just that that kind of absorption enabled the molecules to kind of vibrate or move. So kapag IR ang ginamit mo, thus we have what we call IR spectroscopy or IR spectrophotometry. So meron kayong mga IR instruments sa ating laboratory. And it's very useful because IR spectroscopy will be able to identify functional groups in organic chemistry. Okay, and there are other types of energy transfers here like emission. Okay, UV-Vis din yon. It's just that emission is just the reverse of absorption. Kapag nagkaroon ng absorption yung matter, okay, at a certain point, magkakaroon din ng emission. Okay. And we also have photoluminescence and chemiluminescence. Okay, and these are the various techniques that we are going to study a little bit, okay, one by one. Now, we are done with the nature of light or radiation. And remember, pag sinabing spectroscopy, matter and energy yan na nag-i-interact. So we're done with energy or radiation. Doon naman tayo sa second component niya, which is matter. So matter, ang nangyayari kasi, tulad ng electromagnetic radiation, di ba nakita natin, si electromagnetic radiation, it could behave both as a wave or as a particle. Si matter, ganun din. Okay? But you expect this behavior na si matter ay nag-exhibit both wave-like and particle-like kapag particle siya. So you will have your electrons, protons, neutrons, okay, those subatomic or even maybe atomic or molecular particles. You don't expect matter na bulk, okay, to exhibit wave and particle behaviors, no? Yung mga malalaking matter. Hindi natin usually nakakita yun. But for matter as minuscule as these particles, like molecules, atoms, electrons, you can expect that it will exhibit some wave properties as well. Okay? Now, let's take a look at this diagram dito sa left side ng slide. Okay? Dahil sinabi natin na may wave-like property siya and particle-like, so meaning meron siyang quantum state. Okay? Ang problema nga lang, hindi tulad ng matter at the macroscopic level. Sa microscopic level or sa particular level or particle level, mayroong mga pinagbabawal na transition. So di ba, nasabi ko na kanina may mga energy transition na possible. Because of radiation, pwedeng mag-transition yung electron from one state to another state. Okay? Or, in this case, you can see here a molecule na nagva-vibrate. Okay? That vibration is associated with a certain energy. Pero at this level, sa molecules or atoms, may mga energy level or may mga energy values na pinagbabawal or forbidden. Okay? In other words, energy can only be absorbed or emitted at specific levels. So we have level 1, 2, 3, 4, 5, 6. There is no in between, no? Walang level 2.5, walang level 3.2. Okay? So hanggang dyan ka lang sa mga levels na yan. Okay? That's the rule. Okay? Kumbaga, nature dictated these rules already. May mga forbidden na values of energy. Okay? That's why we call it quantum mechanics, because energy can transition only, can be absorbed, transmitted, translated at certain quanta or states. Okay? So for example, you absorb energy, okay? You excite it with, if you take a look at the yellow one, okay? Nag-absorb ka ng energy up to this level, which is level 6. And then, after you absorb, okay, napunta na siya sa level 6, ang tawag dyan ay excited state. Ngayon, kapag nag-emit na siya pabalik sa level 2, okay, that amount of energy, it turns out, corresponds to the energy associated with the violet part of the visible radiation. Kaya you will see some violet color. And we call this the ground state, yung pagbalik ng transition of energy sa level 2. Okay? Again, there are no in-betweens. Hindi pwedeng hanggang level 2.5 lang siya. So, for example, pag ang ginawa mo naman is level 5 to 2, okay, just like you're seeing here in the blue part, okay, ibang energy naman yon, ibang wavelength, ibang frequency. Okay? So, there are specific energy levels lang. So, it's the same with vibration, no? As you're seeing here. So, yung vibration, the pocket vibration yan, you can just calculate your energy values. No, there are energy states na allowed only. Okay? And the difference between these energy states is the delta E or the amount of energy, yung energy gap na tinatawag natin, which are the energy gap na allowed. Okay? So, application. So, the reason why you're able to use your microwave is that si microwave radiation yung ginagamit dyan. And the reason why it enables heating, it's because yung microwave radiation, it interacts with the moisture or water molecules in your food. And because of this interaction, magiging more energetic yung movement ng water molecules. And this movement of water molecules, okay, dahil mas bumibilis sila, mas gumagalaw sila, nagbibigay sila ngayon ng kinetic energy. And this energy will now be translated to heat. And thus your food will be heated. On the right side of this slide, nakita nyo naman yung applications ng infrared. No? Dun sa topmost, you have here an example of a heat map. So yung ating kapaligiran, there are portions of it na mainit, pwedeng may portion na malamig. So that's how you develop your night vision goggles actually. Okay, so it's because of the IR being emitted. So IR, pwede siyang ma-absorb, pwede ring ma-emit. And here you have an application of IR as well, I think, in the detection of tumor. Kasi it turns out na yung tumor cells, okay, ay, syempre, yung metabolism nila ay medyo abnormal. And it turns out, yung kanilang metabolic heat ay mas elevated. So, ang tawag doon, metabolic heat signature. Okay? And the reason why we can detect them, it's because of those heat signatures. We can detect them through IR emitted. Now, regarding elements naman, ito yung the same diagram that I showed you a while ago. Each element will have a unique energy transition. Okay? So, for example, si hydrogen, you can only see the red, the blue, and the purple. Okay? While for other elements, iba naman yung klase ng energy transition. So, unique ang bawat element. Okay? And we call this we can call it signature if you want. But this is what we call the spectrum, okay, of your element. Now, let's talk about or let's focus on the absorption process. Specifically siguro yung UV tsaka visible part of radiation. So let's say you have here a container and it contains some matter, let's say a solution. Okay. So what you will do is you will apply an incident radiation with power P sub O. Paglabas nung or pag-transmit ng radiation na yan, P na lang siya. It's somewhere less than the incident radiation. Kasi some of the light or radiation is absorbed by the particles. Okay, yung ibang particles dyan probably nag-vibrate. Yung iba naman, nag-cause ng electronic transition. Now, we can measure the transmittance by simply dividing the P by P sub O or yung radiation paglabas ng container over the incident radiation. Okay, but we are sometimes or most times actually more interested in calculating what we call the absorbance. So absorbance is simply the log of transmittance, okay? Or the log of P over PO, okay? So the formula will be A equals negative log of T. Kaya siya negative kasi ang ginagawa natin, it's actually PO over P, no? Sorry, this is a typographical error. So this should be PO over P. Okay, PO over P. Yan yung absorbance. So, in other words, ang absorbance ay just the negative log of the transmittance. Okay, so ito yung formula natin. The negative log of the transmittance. So, regarding absorption, there's a law that governs the relationship between absorption or absorbance and the concentration inside that container. And we call it Beer's law or Beer-Lambert's law. So it's stated in this equation. So absorbance A, which is a unitless quantity, is just equal to epsilon times B times C. So yung epsilon, ang tawag dyan, molar absorptivity. Okay, molar absorptivity. It's a constant for the molecule in your container. If you're going to use a molar concentration unit of, let's say, molarity or moles per liter, so the molar absorptivity should be liters per mole centimeter. Yung B kasi usually centimeter lang yung unit na ginagamit natin. And B is the path length. Okay? There are other terms and symbols employed in absorption measurements. So baka marinig nyo yung mga salita tulad ng, let's say, optical density o kaya extinction. So it's the same actually with absorbance. Usually, ginagamit yung optical density sa biology in cell measurements, no? If you want to get the concentration of cells in a certain sample or other biological molecules, optical density usually yung ginagamit. Okay? Yung molar absorptivity, it's also sometimes called molar absorption coefficient o kaya extinction coefficient. Okay. Now, let's solve this problem. You have a 7.25 times 10 raised to negative 5 molar solution of potassium permanganate. And it has a transmittance of 44.1% when measured in a 2.1 centimeter cell at a wavelength of 525 nanometers. So what we're going to do is to calculate letter A, the absorbance of the solution, and letter B, the molar absorptivity of potassium permanganate. So, to get the absorption, or absorbance rather, absorbance, remember, it's a unitless quantity. So wala siyang, wala siyang dimension, no? Or unit. So remember, A equals negative log times T lang. So the transmittance is 44.1%. So negative log of 0.441 is 0.356. Now, since we know the absorbance, we can calculate letter B, the molar absorptivity. Remember, Beer's law, it's just A equals epsilon BC. So to get epsilon, it's just A over BC. A is 0.356, yung nakuha natin sa part A, and then B is 2.1, and C, it's the concentration. So you will get a value of 2.34 times 10 raised to 3 liters per mole centimeter. So usually, yung mga molar absorptivity, medyo may kalakihan ng kaunti yung values nila. So you don't expect that in a scientific notation na negative yung exponent, no? So it should be always greater than 1. Okay. Now, what if you have a mixture? Okay? So far, ang napag-usapan pa lang natin, isang klase ng molecule doon sa container. Pag may mixture ka, what you will do is to just add the absorbance values. Okay? So to get the total absorbance, it's simply the sum of absorbance 1 and absorbance 2 and so on and so forth. Okay. Now, since ang formula is epsilon BC, so you can also express it as epsilon 1 BC1 plus epsilon 2 BC2. Where epsilon 1 and epsilon 2 are the molar absorptivities of the different molecules. Okay, kasi you have a mixture. And C1 and C2 yung kanilang corresponding concentrations. Now, the limitation here is that there shall be no interaction between or among the various species. Okay? So let's try to solve this problem. The concentration of iron and copper ions in a mixture can be determined following their reaction with hexacyanourethane. So this complex, kasi ganito, no? Usually, ang molecules mo, makakapag-absorb lang siya ng UV or visible radiation kapag meron siyang tinatawag na chromophore. Okay? Chromophore. Ang ibig sabihin ng chromophore kasi, structure siya kung saan may makakita kang conjugated double bond. So pag may double bond ka na alternating, imagine nyo yung benzene for example. Okay? Benzene. Conjugated double bond ang tawag dyan kasi alternating yung placement ng double bond. Okay? That's why benzene is active when it comes to UV or visible radiation. Remember, in your amino acids, there are amino acids that are UV active, and the reason why is that they contain the benzene ring like that. Kasi the benzene ring can absorb UV and visible radiation. So yun yung requirement para makapag-absorb ng radiation na yun. So you cannot really directly have these ions to absorb UV or visible radiation. So what you do is to form a complex with a compound na kaya mag-absorb. Okay? And an example is this, hexacyanourethane. So therefore, both of these ions form a complex. So si iron, it formed a blue-purple complex. And si copper, green naman yung itsura niya. Now, you have here the maximum wavelength of absorption. Okay? And magkaiba sila for each of the complexes. Okay. Ang ginagawa kasi, if you have this spectrophotometer equipment, okay, the first step really, after, of course, maybe after you prepared all the solutions or the samples or the alicos, no? Ang gagawin mo doon sa equipment is i-scan mo muna siya para malaman mo kung ano yung maximum wavelength of absorption. Kasi yun yung gagamitin mong wavelength. Okay? Now, the molar absorptivities for both metal complexes ay nakasummarize dito sa table. So for iron complex, ang molar absorptivity niya at 550 nanometers ay 9970. Okay? But at 396 nanometers, it's 84. While si copper naman, mayroon ka ring corresponding values ng molar absorptivity, okay, at different wavelengths. Now, when a sample containing iron and copper ions is analyzed in a cell with the path length of 1 centimeter, the absorbance at 550 nanometers is 0.183 and the absorbance at 396 is 0.109. What are the molar concentrations of both ions in the sample? So let's do it this way. Pause this video, read the problem again, and try to make sense out of it. Repeat reading hanggang sa maintindihan. Okay? So if you have understood the problem, let's try to solve it. So again, you have here a table of the molar absorptivities of both ions at different wavelengths. And inilagay ko ulit siya dito sa slide na to. Okay? And according to the problem, nung mineasure yung absorbance nung mixture, so this is the mixture already, at 550 nanometers, the absorbance is 0.183. At 396 nanometers naman, the absorbance is 0.109. So what do we do? Remember the fact that the absorbance, if you have a mixture that are not interacting, is simply the sum of the absorbances individually, A1 plus A2. Okay, you only have here a two-component system. So, expanding that, absorbance is therefore epsilon 1 BC1 plus epsilon 2 BC2. Okay? Because magkakaiba ng epsilon yung dalawang component. But B is the same kasi isang container lang or path length ang ginamit natin. But their concentrations, ito yung hinahanap natin. Okay? And you can expect na magkaiba rin sila. Pwede rin hindi. Now, let's consider first absorbance at 550 nanometers. Ano yung absorbance na yun? Ayun no, 0.183. So you'll substitute yung given. So epsilon 1, 9970. Path length is 1. C1 is unknown. Epsilon 2 is 34. Just refer to the table. I'm sorry, it should be, tama, 34. And then, path length is still 1. Now, for absorbance at 396 naman, okay, ano ang absorbance? 0.109. So how do you substitute here? So use number 1, yung 84 na absorptivity at 396. Ito kasi siya, 396 for iron. And for copper, it's 856. Okay, so you have two equations, you have two unknowns. And solve these equations simultaneously. You can use your Excel or you can use your calculators. The answers are the following. So the concentration of iron is this, and copper will be this. So that's basically your Beer's law. Now what's gonna happen next is we are going to discuss limitations of Beer's law. Okay. And the applications. So here we're going to discuss standard curves of your absorbance, which I believe you've been doing in analytical chemistry or chemical analysis in bioengineering. Diba you have a certain measured value, let's say potential, or maybe pH versus yung concentration. Tama ba? So ganoon din yung gagawin natin with absorbance. But there will be another method to analyze your samples, okay, using the standard addition method. And we will look for and discuss applications in biological systems, such as determination of optical density of cells and other biological solutions. Okay, so before we end, okay, make sure that you have subscribed to my YouTube channel, and you can even click the notification bell button para ma-update kayo for our next lectures. See you in the next lecture.